Hello guys, let's do today's problem of the day. Minimum operations to make a uni-value grid. I hope you read the question, else I'll explain the question. They're given a grid of size m cross n and we have to make all the elements into a uni-value grid. What is uni-value grid? It is a grid where all elements of it are equal. How can we make equal? They're given a one operations. In one operation you can add x or subtract x. Like you can take any number and add x to it or subtract x such that we have to make completely into a single element. So, for example, they given it 2, 4, 6, 8 and x equal to 2. And if we want to make into 4, we need to do one operation into this and one operation into this and two operations into this and zero operations. So we need four operations to make the grid into a uni-value grid. So I just we can just observe one thing first of all. And okay, first let's check this example first. 1, 2, 3, 4, and the given x is 2. Whatever you think, whatever value you can you make all of this equal to that value? Let's just take 3. Can you make 1 into 3? Yes, by 1 plus 2 is 3. So by using 1, but you cannot make 2 into 3. So first observation is it possible first of all? If it is not possible, you have to return -1. Okay. So let's take an example. 1, 7, 7, 13. So and given x is 6. So we can check the difference. Here it is 6, 6, 6. So we can make the whole array into single element, whether it is 1 or 7 or 13. Cause the difference is divisible by 6. This is the first observation. As you can see more examples. 1, 5 and 13 is equal to 4. So I can make all the array into 13 by taking two operations of 5 and one operations of 1. Oh, sorry, I want to make 13, right? So I can make three operations of 1, two operations of 5. Or if I want to make 5, I can do two operations of 13 and one operation of 1. Like adding ones 4 to 1 or subtracting two fours to 13 so that it equal to 5. So the first observation is how when it is possible. It is possible when the difference of the elements is divisible by the x. Okay, so this is the first observation. If it is not divisible, then it is impossible to make every element equal. So this is the first observation. And the second observation is which one to pick such that we get the minimum number of operations. Okay, so the best one is to pick the middle one or the median of the array. So for example, if I take this array 2, 4, 6, 8, the same thing, and the median is 4 or 6. So if I take 6, it requires 2, it requires one operation, it requires zero operation, and requires one operation. So it requires four operations. Even if you take 4, it's a median only, right? So it takes one operation for 2 and 0 for 4, 1 for 6 and 2 for 8. It requires 4. So the best one is to pick the median of the array. I hope these are the only two observations required to solve this question. And you can see this is just easy medium. So let's get into the code. First, my implementation is assume it as a single array of size m plus n. So for that, I just took a array of store and I just pushed all the elements into a single store. And then I take median, so I just sorted the array. So what is the first observation? The first observation is the difference of the adjacent elements should be divisible by x. If it is not divisible, I straight away return -1. What is the second observation? How to take the median? So I just took the length of the total n plus m elements and I just took the median and then uh, I just calculated the operations. Like if it is example 1 1, 7, 7, and 13. Let us take 19 and x value as 6. What is a median? Median is 7, right? So, what is from the median? How much it is far away from the median? Like for the one, it is absolute difference of median and the one. It is 6. So I just need one operation. So I'll just divide it by x. So I'll just get right how much time it is dividing it how many times. So I just add into the answer and I'll just return into the answer. I hope you understood the logic and implementation. If not, you can comment out. Thank you so much.